In this lecture, we're going to work through an example of statistical testing, and we're going to relate that statistical testing to a statement of the null hypothesis. And so statistical testing refers to the use of various mathematical equations that will eventually lead us to a decision to accept or to reject the null hypothesis related to a research study. And so one such question that we can ask is the average salary of Toronto Raptors basketball players, and are those salaries different from the rest of the NBA players? Another question might relate to whether consuming 40 grams of dietary protein is any different than consuming 20 grams of protein in terms of generating muscle protein synthesis. And so these are just two examples of research questions that we can eventually subject to mathematical testing using a variety of tests. Some examples of these tests include what's called the one sample z-test, a one sample t-test, a two sample t-test, or analysis of variance that is summarized as ANOVA. So what we're going to do in this example is we're going to use the z-test to answer a research question here. And so to do the z-test, we would need to refresh as to what a z-score is. And a z-score is a standardized score, so the units of the original measurement have been removed, and that's done by taking the difference between a raw score and a group or sample average score divided by the standard deviation, and this produces a unitless value, or stated differently, these are scores expressed in standard deviation units. And the z-score calculation is where we take a single participant's score, so a single case in one group, we subtract the group average for that score, and we divide it by the standard deviation related to that particular group. And so once again here, we started our investigation quantitatively from a research perspective with producing descriptive data, the mean plus minus standard deviation. And once we've calculated that, we would then use those descriptive data into statistical testing. The one sample z-test is a statistical test that will eventually help us to make that, or will allow us to make that decision related to a null hypothesis. And this is a test in which we can arrive at a statement of whether the sample is representative of the population. And in this example, we're going to examine the average salary of Toronto Raptors players, and we're going to ask if that average salary is different from all NBA players. And so to do that, we need what is called the Z equation that is used in the one sample z-test. And so what we see here is that X bar is the average value for the Toronto Raptors players. Mu refers to the population average for the variable of interest, and that's salary. And sigma is the standard, sigma subscript X bar is the standard error of the mean that we will use in this equation, and based upon the size of the z value, we'll arrive at a decision whether to accept or reject the null hypothesis. And so in order to carry this out, we do need some information. And so as part of the data collection process, we might find that by computing descriptive statistics for all the players that on the Toronto Raptors, we would find the average salary is almost $4.4 million per player. Further investigation here, we might find that the average salary for the entire population of the NBA is almost $5.2 million per player. So at first glance, we might look at this and say the average salary for the Toronto Raptors per player is considerably lower than that of all the players in the NBA. Now, what we also need is we need to know what the standard deviation is for the players across the National Basketball Association. And through our research, we find that the standard deviation around the average of 5.1 is $5.2 million, indicating that there is quite a bit of variability in salary structure for players, for professional basketball players. We also need an average value of players per team, and the value we use is that each team has 17 players. We then test the null hypothesis. In doing so, we will have to use the z-test. One of the conditions of using the z-test is that we must have these numbers right here. We must know the standard deviation of the population, and we happen to have that data here available. So in stating the null hypothesis, we're basically going to start with a null hypothesis that the average salary of the Toronto Raptors player, symbolized by mu, is going to equal the league salary average of almost $5.2 million. And it's a null, so which is to state that there's no difference between Toronto Raptors salary and the NBA average salary. We then follow that up with the alternative, and in this case, we're going with a non-directional alternative, and we're just simply going to state that the difference is not equal to the particular salary for the entire league. So with the one sample z-test, once we have our data, so once again here to review, in order to carry out the one sample z-test, we need to have our sample average. We need to know the population average to which we're comparing that sample to. We do need to know the standard deviation, which we don't always know, but in this case, we do happen to know the population standard deviation, and of course, the sample size and the number of players per team. That's reflective of the Toronto Raptors. So knowing that we're going to do the z-test, we're going to start with the standard equation for the z-test that you see here. Now, in order to carry out this equation, we would take the average salary of our sample. Our sample here is the Toronto Raptors, and we put this into the equation, as you can see at this point, and then we subtract the population average, which is the average salary for the rest of the league, and we divide it by the standard error of the mean of that population. And so the equation, recall, is the population average divided by the square root of the sample size. And so in this particular case, because the sample size is 17, we substitute the population average, the population standard deviation, and divide it by the sample size, and we have a standard error of the mean of over $1.2 million. Substituting that into the equation, now the unit for the numbers is the dollar. That cancels out, and we have a z-value of negative 0.63. Now, what do we do with this value here? We now have to go back to the distribution that this equation is modeled upon, and that distribution is the normal distribution. And recall that the normal distribution, we have what's called a non-critical region and critical regions in the tail regions. And for most studies, and in this particular study, our standard of risk for a type 1 error is going to be 5%, as it is in many research studies. And so if we are going to conclude that there's going to be a difference, we're willing to risk that our statement is wrong 5% of the time, which is to state that we have 95% confidence in our statement if we reject the null hypothesis. So in this distribution here we see the x-axis, which is a measure of the outcome variable or the dependent variable in standard deviation or z units here. And the z value of plus minus 1.96, it's almost 2 standard deviations, not quite, and it's at that level where we see the 95% of the area under the curve that is captured. And if our calculated z value falls anywhere between negative 1.96 or positive 1.96, then we accept the null hypothesis. We don't reject it because it is contained within the 95% level of confidence. Only when our calculated z value falls outside of this 95% area, for that to happen, the calculated z value from our statistical testing has to be a value greater than 1.96 or less than 1.96. And that would put our calculation into what is called the critical region, split between the lower level and the higher level, 2.5%, 2.5%. So if our calculation leads us to believe that, or if our calculation lands us in the critical regions, then we can state that with 95% confidence that that value is different than the vast majority of cases here, the vast majority referring to 95%. Now, going back to our specific example, we calculated a z value of negative 0.63. It's negative, and that reflects the fact that the average salary of the Toronto Raptors player was actually less than the population average. So 0 indicates the population average of $5.193 million. The average salary for the Toronto Raptors was $4.392 million. So it's going to be to the left of 0 in the negative z range. Now, the question we originally asked, is that significantly different? And we find that the z value lands within the 95% non-critical region. So we would conclude that that HO is true. We accept the null hypothesis, and by accepting the null hypothesis, we state that the average salary for the Toronto Raptors player is not significantly different than that of the entire National Basketball Association, despite the fact that the average values are different. That highlights the importance of incorporating of the statistical equations that need to incorporate the variability in the data as well. And so just to recap the steps involved with hypothesis testing related to a research study, the first step is to always state the null hypothesis in symbols. Oftentimes we would follow that up in words with a sentence, and so that would state with our previous example that the null hypothesis states that there will be no significant difference in salary between the average Toronto Raptors player and the entire league. We then follow that up with the alternative hypothesis. In our example, we used a non-directional alternative hypothesis, stating simply that it will not be equal. We would then choose the alpha level. Most often, the 5% level is chosen, and most oftentimes we use what's called a two-tailed approach, in which that 5% is split between the upper tail and the lower tail. We then would state what's called the rejection and retain rule, which is something that we'll see in a subsequent unit. And following that rejection and retain rule, we would then compute the appropriate statistic, as we did in the immediate previous example with the z-test. We then make a decision by evaluating the reject-retain rule that we established in number 4 that we'll address in the subsequent lecture. And then we write the conclusion in the context of the study. So this ends our final part of our Unit 8 lecture on statistical inference.